All right. Okay, this is the nth root test. This is our last test. The nth root test is similar to all the other tests. It just says that if you have a series with all positive terms, and note again, all positive terms, that we can look for the limit as n approaches infinity of the nth root of the nth term of that series and find its value. Find that limit, find what L equals. And if that limit is less than 1, the series converges, absolutely, because it's all positive terms. If that limit is greater than 1, the series is divergent. And if that limit is 1, then once again, it's inconclusive. It could be divergent, it could be conditionally convergent, it could be absolutely convergent, it could be any of those fun things. Okay? Everybody good with that? So it's very similar to what we looked at with the ratio test, right? If it's less than 1, converges. If it's greater than 1, it diverges. And if it's equal to 1, find a new test. And so sometimes, sometimes this test will be helpful. The chances of you needing this on the AP test are fairly slim, but you never know. So we will talk briefly about it. Yeah, I mean, if he comes in Zoom, if he asks to join my Zoom meeting, I'm just gonna decline. I'm just gonna boot him. Just kidding, Austin, if you're watching this video on YouTube when I post it later, of course we'd let you in. All right, so anyway, we're gonna take a look at this series, the series from the sum from n equals 1 to infinity of n to the n over 2 to the 2 plus n, okay? Which we probably could look at that and just by some basic like thought processes, figure out what we think, whether it diverges or might converge for some value or converge for all values. But we can be guaranteed of that by taking this nth root test with it. And so the nth root test is good when you've got something to the nth power and something else like to some sort of nth power in both the numerator and the denominator of a fraction. And you're not sure whether the top or the bottom might be increasing more rapidly or something like that. And it's just a good way to prove it. So we are going to, first off, think about whether this has all positive terms. Does this have all positive terms? Because that's always the first thing we want to check. All positive terms. Okay. All positive terms. Everybody at home good that that's all positive terms?
Yep.
Okay, wonderful. Okay, so we're all positive terms. So now we're going to just instead of looking at this thing's limit, you know, we could try the ratio test or thing, but let's just use the nth term test. So let's say, what's the limit as n approaches infinity of this thing to the 1 over n, that'd be the nth root, right? So normally we'll do it this way. We'll just say to the power of 1 over n, right? Because x to the 1 over n, we should know is the same as the nth root, right? Okay, perfect. So, well, this is just a fraction that's being raised to a power, right? Fraction being raised to a power means you can just distribute that power to both the numerator and the denominator. So what is that going to give us? It's going to give us the limit as n approaches infinity of n to the n for the 1 over n should be just n. And in the denominator, 2 to the 2 plus n should become 2 to the 2 over n plus 1. Exactly. And now we should be able to look at what happens to that as n goes towards infinity. The numerator as n goes towards infinity is, and the denominator is 2 to the 0 plus 1, so 2 to the first, or just 2. And half of infinity is still infinity, and we should be able to state that this diverges by nth root test. People at home, are you good with that?
All good.
All good. People here, the 3 of you here in this wonderful hybrid learning environment. We're all good? All right. Cool. Sum from n equals 0 to infinity, 2n minus n cubed to the n over 8n cubed plus 1. All to the n. Should be an easy one. Good one for the nth root test. Why is this a good one for the nth root test? Yeah, just cancel out the ends, right? So does this have all positive terms, first of all? I don't know, you tell me. The top, right? If I'm going to n values greater than 0, I'm going to have 2n minus n cubed. So that could potentially be negative. In fact, it's going to be negative most of the time. The denominator is always going to be positive. So we're going to have a negative number being raised to the first, the second, the third, the fourth, the fifth. So sometimes we're going to have negative terms. Did y'all agree that some of those terms are negative? Zoom?
Agreed.
Agreed. Okay. So sometimes negative. So what will we look at? We'll look at the absolute value, right? So we're going to say, we're going to do the nth root test. So we're going to say, what's the limit as n approaches infinity of the absolute value of 2n minus n cubed over 8n cubed under 1 at the end of 1 over n. And what can I do with that? The n to the 1 over n conveniently will just disappear, right? It cancels out. So we've got the limit as n approaches infinity of the absolute value of 2n minus n cubed over 8n cubed plus 1. And that gives us a limit of 20, which is that's right. It's less than a lot of things, Noah. Very good.
I didn't write down this part.
Same as the ratio test. Less than 1 converges, greater than 1 diverges, equal to 1 inconclusive. And 1/8 is less than 1, therefore we will say that this converges. Easy enough, we get the idea. Everybody feel like you could do these? Generally speaking, take a look at what's in the numerator and what's in the denominator. And if they're both being raised to some power that involves n in them, the nth root test is sometimes a good choice. It doesn't take that long to try and figure out. If it comes out to be inconclusive, try a different test. Good. All right, and that's enough of those. We don't really need to do another one. Let's move into what we're going to spend the rest of the day doing today, which is piecing everything that we've done with all of these different tests together to take some power series and determine the interval of convergence for it and figure out when it converges absolutely and when it converges conditionally, what its radius of convergence is. And this is going to fully include us checking the endpoints. Like I've been saying this whole time, you got to check the endpoints, but we don't have all the tools to check the endpoints yet. Right? We got to check the endpoints, but we don't have all the tools to check the endpoints yet. Well, now we've got all the tools to check the endpoints. Okay? So what we're going to do is we're going to start off almost every single one of these by looking at the ratio test, and then hopefully the ratio test will work out. If it doesn't, we'll take a different test to try. And then once we've determined the base interval of convergence and what the radius of convergence for the series is, we're going to evaluate the series at each of the endpoints, and then use some other tests to determine if the series converges at those endpoints. We will also have to go through and pay careful attention to whether we've taken the absolute value of the series, and when we're checking the endpoints, we're going to have to pay careful attention to whether taking the absolute value, whether those series are always positive or whether they're alternating, and whether we have to take the absolute value to determine absolute value or absolute convergence at the endpoints, all that fun stuff. Okay. So we're gonna work through, I don't know, however many more of these I've got, probably like 5 more throughout the rest of this period. That's our goal for today. And this will be end. This is the end of material. Hopefully, assuming we get through all of this today, we'll be done. We'll have covered everything for the AP test. Sound good? All right. So when we test the power series for convergence, like I said, the first step is we're going to use the ratio test. That will help us to figure out when the series converges absolutely. Okay. So we have 3 different options for that, right? One is that it might be infinite, right? We might end up with r is equal to infinity, right? So that we know that it converges for all real values. In which case, we would just say that it converges absolutely for all real values. The radius of convergence is infinity. It doesn't ever conditionally converge, right? Because if it converges absolutely for all values, it's never going to converge conditionally. Remembering that, what does it mean to converge conditionally? Not necessarily that it alternates. It could have like positive, negative, negative, positive, negative, negative, something like that, right? It means what? No, it only converges. Okay, conditional convergence means that the series converges, but that the absolute value of that series does not converge. Okay, so conditional convergence is the series converges, but the absolute value of that series does not converge. So if you make all the terms positive, it no longer converges. So yes, it would have to have some negative terms in it, but they don't necessarily have to alternate. Now, 99.9% of the time, they're going to alternate. We're going to deal with what's right? Especially for this. Okay, so one option was r equals infinity. Another option is r equals 0, right? The radius of convergence is 0, and it will converge specifically only at a, right? Whatever a value we're centered around for our series. So it might only converge there because that will make the series just 0 plus 0 plus 0 plus 0 plus 0. And then the third option is that we have some finite interval of convergence that is greater than 0. So, it might converge for 1 to 3. And so if it converges for 1 to 3, absolutely, by using the ratio test, then we have to check at the endpoints of 1 and the endpoints of 3, whether it converges and whether it converges absolutely. That way we can indicate, we'll say that it, let's say it converges at 1. Right, let's do this. Let's say we got a radius of convergence of 1 and our interval was 1 to 3, and we knew that it was absolute because we used the ratio test. 1 to 3 absolutely. We would check at 1. Check at 1. And if it converges, let's say check at 1 converges. Great. Let's say then we check the absolute value of the series at 1. And let's say that diverges, right? That's a possibility, right? Then let's say we check 3, and we find that 3 converges. And we check the absolute value of the series at 3, and we find that that also converges. So in that case, what we would write out in the end is we would say that the radius of convergence is 1. The radius of convergence is 1. We would say it has absolute. Well, actually, let's do this first. I would say it converges on, and then I forgot what it said. It converged at 1 and it converged at 3, right? So we would say that it converges on the interval 1 to 3. We would say that it converges absolutely, and we said it didn't at 1, right? So absolutely 1 to 3, and we would say that it converges conditionally at 1. Does that make sense? If that's, that's the situation we're doing. We found that it converged absolutely on 1 to 3 initially, and then we check the endpoints, both the regular series and the absolute value of that series, and we would write out all of this information, and this would be your final answer to whatever series question I gave you that had all this that happened. Okay, so does that make sense, everybody at home? Oh, this is a Zoom chat. These alternating series tests on the radius of conditional convergence. Yes, you can use that, Kevin. That works. But we're gonna, as we go through all the different steps, Kevin, we'll be able to find that we'll be able to find that radius of convergence, the radius of conditional convergence, just by using all the other steps that we're using. Anybody else have any questions before we get started with one of these? Sure. People at home, are you all good? Anybody have any questions on anything before we do this next problem? Wonderful. You good? Y'all good here? You good there, Mr. Lawson? That's good. We'll see. All right. Okay, so we're going to look for like all those things that we were just talking about a second ago. Here we're talking about the radius of convergence, the interval of convergence, when it converges absolutely, when it converges conditionally, given this series here, -1 to the n plus 1 x to the 2n over 2n. Okay, from n equals 1 to infinity. Huh? Everybody good with conceptually what we're about to try to do? Yeah. Zoom?
Zoom's good.
Zoom is good? Okay, perfect. All right, so what's the test we're going to start off with here? Okay, ratio test. No, it says ratio test. Everybody agree? Ratio test. We're going to use ratio test to start out every single one of these. Okay? So first thing we have to look at then for our ratio test is for all values of x, is this series always positive? Why not? Okay, because it's alternating. Okay, everybody at home, you see that this alternates. The -1 to the n plus 1 is making this alternate, correct?
Yes.
Yes, okay. If we did not have a -1 to the n plus 1, would this series be positive for all values of x? It would be because we're getting even powers, right? But we have the -1 to the n plus 1, which is going to make this thing alternate. So when we use the ratio test, what do we have to do? We have to take the absolute value of it. So we're going to look at the limit as n approaches infinity. And then with our ratio test, that means we're looking at the ratio between the n plus first term and the nth term. So we're looking at, and we're going to put this in absolute value. And when we do this, the -1 to the n plus 1, when we take at the n plus first term of that, and we look at the nth term of that, the -1 to the n plus 1 is really just like a 1 or a -1. And so when we throw those in absolute values, those all just become ones, right? Everybody agrees those all just become ones, and all those are going to not matter at all anymore. So when we throw all this stuff into our absolute value, the -1 to the n plus 1 can be eliminated completely. You guys good with that on Zoom?
Good.
Okay. So I am not going to write the -1 to the n plus 1. Okay. When we write this out, we're going to be careful because x to the 2n, we're replacing the n with n plus 1. So this does not become x to the 2n plus 1. Right? What does it become? It should become 2n plus 2. I'm going to write it as 2 times n plus 1. Right? Everybody good with that? I'm just going to put it like that, just for the sake of replacing the n with the n plus 1. We'll simplify in the next. Okay. Everyone's good there? Okay. And then the same thing with the 2n should be 2 times n plus 1. People at home good with that?
Yep.
All right, you guys here good? Yeah. Okay. All right, and so we're dividing by the nth term, which means we're going to multiply by the reciprocal of the nth term, which means we're going to get a 2n and we're going to get an x to the 2n. And then we need to simplify down some terms, right? So what does it look like when we simplify down our terms? Still inside an absolute value, right? The x to the 2 times n plus 1 over the x to the 2n should become what in the numerator? You sound a little unsure of that. X squared, yeah? We all feel okay about x squared in the numerator? I wouldn't do that if I wasn't trying to instruct people. I just want to make sure that we replace the n with n plus 1, not write it down accidentally as 2n plus 1. Yeah. You guys at home good with that? X squared in the numerator from the x to the 2 times n plus 1 over the x to the 2n?
Sounds good.
Yeah, okay, perfect. So we've got x squared in the numerator. We've also got the 2n, and we've also got a 2n plus 2. The 2n in the numerator and the 2n plus 2 in the denominator. Yeah? And then as n, I forgot to write my limit as n approaches infinity. What is the limit as n approaches infinity of x squared times 2n over 2n plus 2? What happens to the 2n over the 2n plus 2? As n goes towards infinity, those have the same degree, right? They're both degree of 1, so you divide the coefficient, which is just 1. So we just end up with a limit of absolute value of x squared. Okay. And so according to our ratio test, what do we have to do with this absolute value of x squared? We have to figure out when this thing converges, to find our interval of convergence, we have to do what? What does the ratio test say? If the value of your limit is less than 1, then it should converge. Good, there, you guys all good with that? So we have a limit that's come out with a variable in it. So whenever that happens, anytime that happens, set it less than 1. Okay? We know that x squared is always positive or equal to 0 no matter what. So the absolute value is redundant. We can get rid of it. So we're just really looking at when is x squared less than 1. And we should know that x squared is less than 1 when x is negative 1. Right? So what do we have here? First off, we're given, we've got our interval of convergence, right? Our base interval of convergence from -1 to 1, which tells us that our radius of convergence is what? 1. People at home, are you all good with that? That the radius of convergence is 1, and that this series will converge absolutely from -1 to 1.
Yeah.
Yeah, everybody, any questions? Y'all are good here too? Yeah. All right, perfect. So next thing that we have to do, and this is the step that we're adding in, this is the step that we haven't been doing before. We have to check both of the endpoints. We have to check at -1 and we have to check at +1. Okay? So we're going to go back to our original series. Our original series was the sum from, I forgot what it was now. What was it? N equals 1 to infinity. And we have -1 to the n plus 1, x to the 2n over 2n, right? So that was our original series. So now we got to check it at -1, we got to check it at 1. Anybody care which one we do first? Nobody cares? -1. No one wants to do -1. Everybody good with that? I don't care. We're going to do it. All right, so what we've got here is -1 to the n plus 1. Then we're going to replace the x with the -1. We're going to replace it with our endpoint. So we got -1 to the 2n. And we got a 2n in the denominator. So now we look at this and we say, all right, -1 to the n plus 1 times -1 to the 2n. Those have the same base, so what can we do with them? We can add our exponents, so that's going to give us -1 to the 3n plus 1 over 2n. So this is the sum from n equals 1 to infinity of -1 to the 3n plus 1 over 2n. Everybody feel okay about that at home?
Yeah.
Okay. What can you tell me about -1 to the 3n plus 1 if I plug values of n into that? So if n is 1, what's the power going to be? 4, right? So we're going to get a +1. What if n is 2? It is? What about when n is 2? Then it's odd. So immediately the second one, it was not. Yeah, it would change, right? Yeah. So this is going to alternate still back and forth between positive terms and negative terms. When I put an odd number in here, we're going to get an even power. When we put an even number in here, because we're adding the 1 to it, we're going to get an odd power. All right, so this is still going to alternate. So we can just effectively call this the sum from n equals 1 to infinity of -1 over 2n. Right, but not -1, -1 to the n plus 1. Right? And we can just keep, it's going to keep going back and forth and back and forth and back and forth. And so we have 3 criteria for an alternating series to show whether it converges, right? Alternating series test. We talked about this one yesterday, I think, right? First criteria is that it has to alternate, right? Does this alternate? We just proved that, right? No. Criteria 1, this alternates. Criteria 2 is what? Right. If you take the absolute value of each of the terms, say that again?
Take out the -1.
Well, that's criteria 1. But those are changing stuff. That's criteria 1. Yeah, criteria 2. I think you got those mixed up. Right? Those are the same. Those are the same thing that you were just saying. Okay. Criteria 2 should be. Anybody got criteria 2? That it is always decreasing. Oh, we got it. We got it here. Yeah. Yes, Kevin, exactly. If you want to factor out the 1/2, that is perfectly fine. And you get the alternating harmonic series. And yeah, if you factor out the 1/2, you get the alternating harmonic series, which we know converges. And we're basically going to just show that this converges by the alternating series test anyway. But yeah, factoring out the 1/2 is a perfectly acceptable way to do it. As Noah said, the second criteria, he finally got it here. The second criteria is that these terms need to be decreasing if we take the absolute value. And so we can see that these are decreasing, right? If I plug in n equals 1, this becomes a 1/2. If I plug in n equals 2, this is a 4. If I plug in n equals 3, it's a 6, right? And then it's an 8, and then it's a 10, and so on. So these are decreasing. If we go down to the third criteria says that the limit as n approaches infinity of that nth term, a sub n, needs to be 0. And if I go towards infinity, if I throw an infinity down here for n, this is 1 over infinity, which we know is 0. It's like just our known fact. So meets all 3 criteria of the alternating series test. So we will say that this converges by the alternating series test. Okay. So it converges at -1 at that endpoint. Now, that's not all we have to do with -1. So the rest of this new piece of this is we also have to determine if the absolute value of this converges, because that's the absolute convergence piece. Everybody at home good that we need to now take the absolute value of this series to show absolute convergence, or whether it does converge absolutely at that endpoint?
Yeah, makes sense.
Makes sense? Yeah, everybody good?
All good.
All right, so we came up with this eventually when we simplified it down a bit, right? -1 to the n plus 1 over 2n, right? And so we know that this, when we take its absolute value, is just going to equal what series? The sum from n equals 1 to infinity of the -1 to the n plus 1 inside the absolute value, just like it did earlier in the problem, just becomes a 1. So we end up with 1 over 2n. You all good with that? Jenna, you're good with that? Yeah. Everybody at home good with that? That the -1 to the n plus 1, once it's inside the absolute value, is just a 1?
Good.
Okay. All right, so what do we know about this series? By the what series? The P series test. This is a P series, right? This is a P series with a degree of 1. We know that this diverges by P series. And on the AP test, you're going to indicate that this is divergent by the P series test. You have to give a reason. And just like we said that it converged by the alternating series test, you're going to tell me that it diverges by the P series. Everybody good?
Yep.
Let me see, what does this say? On the AP test, instead of writing out all the tests, if I write the alternating harmonic series is conditionally convergent. So Kevin, I would be fine with that, but on the AP test, they want to see the work for both the series itself at -1 and the absolute value of the series at -1. So they're going to want to see both of those things. Otherwise, they're not going to give you all the points for it. They want a different reason for each one why it converges or diverges. It is a little bit redundant. That's just their rules, though. So unfortunately, you kind of gotta stick with what they want to see to get all the points. Does that make sense? Yeah. Okay. Cool. All right. So we know that it converges at -1, but does not converge absolutely. Okay. So then we got to move on to the other endpoint. Right? We got to move on to x equals 1. So we'll do that. At x equals 1, it's been a long time since I've written this series out. It was n equals 1 to infinity of -1 to the n plus 1 times x to the 2n, right? So we're looking at 1 to the 2n over 2n. And as we go through and do this one, first thing we'll note is that this becomes what? It just becomes -1 to the n plus 1 over 2n. That 1 to the 2n is insignificant. It just is another 1 that's thrown in there. And we'll see that then what's happening here? Does this converge or does this diverge? It's the same thing as what we just dealt with when we plugged in -1, right? So we will say that this converges. Why does this converge? Again, by the alternating series. Everybody good there? People at home good with that?
And I assume if we're on the test, we don't actually have to like list out all the criteria again if we literally just did it right.
Yeah, that is correct. You don't need to rewrite those criteria. Yeah, you're correct. All right. And then so now when we take the absolute value, and I'm just going to write this down at the bottom. Absolute value at x equals 1. And we're going to end up with what? We're going to end up with just 1 over 2n. Which we know diverges again by T series. Good or no? So our final answer to all of those questions would be the radius of convergence was 1. Yes? We would say that the series converges on what interval? Inclusive -1 to 1. We would say that it is absolutely convergent only -1 to 1, non-inclusive. And we would say that it is conditionally convergent at x equals -1 and any questions on that? You guys, I don't know how long ago did I cut out of Zoom?
Conditionally convergent.
Okay,
So
it's conditionally convergent at -1 and 1. Done. Everybody good with that? Anybody have any questions on that? Y'all good here? Yeah. People at home, you're all good?
Could you go back a page real quick?
Sure.
Okay, thank you.
Sure.
Yeah.
All right, let's take a look at this one. So first thing we need to think about is, are all the terms positive? Are all the terms positive for all values of x? No. Right. I mean, put in x equals any negative number and immediately 10x is not negative, right? So not always positive, which means we're going to have to take the absolute value of the series when we do the ratio test. Everybody good? Kevin, yeah, not possible to have more than the 2 endpoints. Yeah, just the 2 endpoints are all we'll be looking for. All right. So we're going to take the absolute value. we're going to do the limit as n approaches infinity of the n plus first term of the nth term. So limit n approaches infinity. N plus first term is going to be 10x to the n plus 1 over n plus 1 factorial. We'll multiply by the reciprocal, n factorial over 10x to the n. Throw it all inside absolute value and simplify. What does that simplify to? (10x to the n plus 1 over 10x to the n should just be 10x. And n factorial over n plus 1 factorial ought to be n plus 1 in the denominator. That go right there? Okay. I just don't have good handwriting, Derek. Come on. I'm sick of these personal attacks. Okay. Okay. So we have absolute value of 10x over n plus 1. Well, as n goes towards infinity, what does that equal? Should be, no matter what x is, should equal 0. What does that mean? It converges. In fact, it converges absolutely. Or negative infinity to infinity. Your limit was 0. No matter what value of x you plug in there, that limit is 0. So no matter what, this thing converges absolutely, which means that there is no conditional convergence, which you will state if it asks when does it conditionally converge. You will state that it has no conditional convergence, and you will say that the radius of convergence is infinity. And since you've stated that it converges absolutely for all of them, if there's no conditional convergence, there's no need to write just a base interval of convergence as well. Everybody good on that one? Easy one? That one's a lot easier. No endpoints to deal with, right? Life is good.
Do we have to state that absolute convergence implies convergence and then write again the interval of convergence, or no?
No, you do not need to.
Okay, cool.
Yep. Any other questions?
Is the fact that it converges absolutely because the limit equals 0, or because it's less than 1?
It's because it's less than 1, but it converges because it's less than 1. It converges absolutely because we have to take the absolute value of the series. That's what makes it converge absolutely. Terms of this series, it could have negative terms into a series with all positive.
All right, but is the thing that tells us that the fact that the limit specifically equals 0, or because it's less than 1?
Less than 1.
Okay, thank you.
Any other questions on that? Let's do another one. N equals 0 to infinity, n factorial times x plus 1 to the n. Does this have all positive terms for all values of x? No. Plug in -7 for x, and the second term is negative, right? Easy, right? So not all positive. So once again, we will use the ratio test and take the absolute value. So we're going to look at the limit as n approaches infinity of the absolute value of, instead of n factorial, we'll have n plus 1 factorial times x plus 1 to the n plus 1, and we're dividing by n factorial x plus 1 to the n. And we will then simplify and see what we get. So what does that simplify to? The limit as n approaches infinity of anybody? N plus 1 times x plus 1. Everybody agree? Yeah? What does that limit equal? Okay, Derek says that limit is infinity. I almost agree with you. It's infinity most of the time. Like almost all the time. It is infinity if x does not equal -1. Right? Because if x is -1, then I have 0 times n plus 1. What's 0 times n plus 1? No. What's 0 times n plus 1? Forget about this. What's 0 times n plus 1? 0. Okay. Now, what's the limit as n approaches infinity of? 0. 0. Right? So this is infinity if x does not equal 1. It's 0 if x equals 1. Remember that the variable inside of this equation is n. X is just some number. Okay? We are investigating what happens to the limit as n approaches infinity. What happens to all of this as n goes towards infinity for each individual value of x. So for the individual value of x equaling to -1, we simplify first. 0 times n plus 1 is 0. And the limit as n approaches infinity of 0 is 0. So this is equal to infinity if x is not -1. And it equals 0 if x is -1. So we will say that this has a radius of convergence of 0. And we will say that it converges absolutely at x equals -1. It has no conditional convergence. And this is the entire interval of convergence. This is the entire convergence at -1. No conditional. You might state if you wanted to, but you don't need to because it didn't ask you to, that it diverges everywhere else except at x equals -1. Which makes sense, right? I mean, if I plug in any other number into this n factorial is going to get larger faster than, something that's smaller than 1 going to the nth power. The n factorial is still bigger than that. And for any other value, this is getting, anything outside of -1, -2 to 0, this thing is getting bigger, and this is getting bigger, getting huge. That should make sense. Good? Zoom questions or no?
This might be a dumb one, but could you explain how R is 0?
Yeah, that's just a sort of the definition of the radius of convergence. If it converges at one specific value, then there's no interval. So we say the radius of convergence is just 0. There's no, it's just at that singular value of -1.
Oh, yeah, never mind. That makes sense. Sorry.
That's fine. No need. Home good or no?
Yep, we're good.
Okay, we're getting down to it here. You guys want to do this one on your own? Okay. This one will be more like the first one that we did. More like. Not saying it's exactly like it, but more. Okay, I'll give you guys about, I don't know, maybe 10 minutes or so to work through this. That should be good. So you'll have to find the radius of convergence, find the interval of convergence, check the endpoints, and check the absolute value of the endpoints and see how you do. Give you about like 10 minutes.
Thanks, Aya.
For all values of x, is this positive? No, not all positive. So we will look at the limit as n approaches infinity of the absolute value of the n plus first term 2 times n plus 1, or 2n plus 2, and then 2n over x minus 3. Everybody good with that? That should have simplified down to just the limit as n approaches infinity of x minus 3 times 2n over 2n plus 2, which should just be absolute value of x minus 3. Since that has an x in it, we'll set it less than 1, figure out when that's true. But we will note that what is the radius of convergence? Right away from here, since its absolute value of x minus a is less than our radius of convergence. So our radius of convergence is 1. And then we would find the interval. The interval would end up being x is less than 4, greater than 2. So we have a base interval of convergence of 2 to 4, and we need to check the endpoints of 2 and 4. So if we check 2 at x equals 2, this becomes the sum from n equals 1 to infinity. It was x minus 3, right? So that's negative 1 to the n over 2n. And we would be able to say that that converges by the alternating series test. Yeah, you want to say that it's alternating, that it's decreasing, and as it goes towards infinity, it's 0. Yep. And then that means that it converges by the alternating series. Yep. And we'll say absolute value at x equals 2. Then that would tell us that we'd end up with what? That'd be the sum from n equals 1 to infinity of just 1 over 2n. And that we would say diverges by these series. Good? Good with that? All right. Then we'd say at x equals 4, we'd end up with 1 to the n over 2n, right? This series is always positive. So we're not going to have to look at the absolute value of it, because this series and the absolute value of this series are the same. And so this we know diverges again by the p series. And so we had convergence at 2, but not absolute convergence at 2. We didn't have convergence at 4 at all. And we should be able to write out r equals 1. We would say that it converges on 2 to 4. We would say that it absolutely converges solely on 2 to 4, non-inclusive on both. And we would say that it has conditional convergence only at x equals. And that would be that. Everybody good with that? Anybody have any questions on that? Good, good here. At home, you're all good?
Good.
Great. You'll probably note that I threw up a bunch of assignments last night in Google Classroom, probably like 10 of them or something. There was a couple series one there was like basic Taylor series stuff that I meant to post earlier. I put the more complicated Taylor series one up, but never the basic one, so that's up there. I also put up one for the ratio test and the direct comparison test, or the limit comparison test, one or the other. I'm going to put one more series assignment up that's called like final series assignment, where you have to do a bunch of these. And that's what this week's quiz will be on, basically doing this, and what we just did. So that'll be this week's quiz. I also put up a bunch of free response questions for you guys to start working on. I know I'd already put up the series and some area and volume ones. We've only got a little bit of time. We're gonna basically just jump straight here from today. Tomorrow we're gonna start. I'm not gonna review this stuff tomorrow. We're gonna do series FRQs and area and volume FRQs. And then for the few people that are doing the May 4th test, I just want to make sure that I introduce all the other types of FRQs that might show up so that you've seen them. I think it's just Kevin and Sri, but I just want to make sure you've seen them before May 4th. And we're going to spend more time doing them after May 4th, but we're going to do as many as we can before May 4th as well. Everybody good with that? All right, so